Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, all paths from source to target. So in this question, we would be given the directed acyclic graph, which we abbreviate as DAG, of n nodes labeled from, let me directly show you, labeled from 0 to n minus 1. Find all possible paths from node 0 to node n minus 1 and return then any order. Means basically it's 0 to 1. If this is the only graph being given to us, so we can clearly see that there is only one path, that is this one. So we are required to return this one path, means we are required to return 1. But if there are more nodes than this, means our starting node is always 0 and our ending node is always n minus 1 node. That is 2 which would be there. So here if we see, here we can clearly see that there is only one path, but there could be possibility that if it is also connected, then now there are two paths. So this is what we are required to learn, that is 2. Now comes the next part, that if there is some graph which is being given to us like this, 1, then 2, then 3 is also given to us. So there, if graph is like this, or if it is also like this, or if it is like this also. So here we can directly see that here one path is this one, then one path is this one, that is two paths. Now, this is the third path, and this is the fourth path, right? So now total here are four paths. So we are required to return 4 here as our answer. But there could be possibility like if this path doesn't exist here, right? So now there are only three paths. So we will be returning 3. And if there could be possibility that if this node is also not there, or basically this edge is also not there, node is there, edge is also not there, right? So here we can clearly see that now we are having 1, means this 1, and then this 2. Only two paths are there which are being connecting our 0 node to our n minus 1th node, that is this 3. So our answer would be 2. But at max there was possibility of the number of nodes which are being there, right? So how I can explain you, like there are total 4 nodes, right? So apart from this, see, if there is 0 to 1, two nodes are there, right? So possibility of path first, number of nodes, that is 2 minus 1, not minus 1, minus 2. So 2 raised to power 0 path, that is one path was there. If 0 to 1 is there and 0 to 2 is also there, and like this is also there, and one more path like this is also there. No, no, no. Means if this is also there, right? So their total possibility was total number of nodes, that is 3 minus 2 is equal to 2 raised to power 1 paths were there, right? But there could be possibility that this path is not there, right? This edge is not there, so here only one path is there. Basically, I'm saying that it maps 2 raised to power 0, 2 raised to power 1. So as per the number of nodes, there could be these much paths. So that is the thing here. But now the main question is that whatever path is being present in this particular graph, which is being given to us, so how many exactly paths are there? So that is what we are required to do in this question. So now let us first see the constraint, then we will be going ahead with the intuition part of this thing. Now here n equals to graph dot length, then r n would be lying between 2 and 15. That is length of the graph would be up to 15. Means total nodes could be 15. Then graph of ij, there could be total n nodes only. And then graph of ij is not equal to I, that is there will be no self loop. And all elements of graph of I are unique. And the input graph is guaranteed to be dark. Means there is no cyclic paths. It would be always acyclic. So that they want to convey to us. Now comes the next part, that how we are required to do this question. So for that part, see, first question comes to mind when there is a question like this. that is it sufficient enough to traverse into the same? And when we are required to traverse the same, then how we are required to traverse it? Means either we can follow BFS or we can follow DFS, or even there are portions of some graph questions where DP can be also used. But here we are not required to use DP. We don't need to store anything here for a reference for future use. So that's why DP is not required. But here only simple traversal is required because we are required to check that how many paths are there from 0 to n minus node. There could be multiple paths and at max there could be 2 raised to power n minus 2 paths. That is the thing. But presently, we don't require that upper limit for solving a question. We just require to do that question by directly doing either DFS or DFS. So for this question, I will be doing DFS for the same, in just for traversal part. Now comes the part that do we require to make adjacency list out of this edges which are being given to us. So the answer is that no, we don't require to use adjacency list because the way they have given to us, we can directly utilize the same. See, they have given to us 1 and 2. That simply means that 1 is connected with 2. And we can use this fact and use it further. Then 3 which is given to us. And then again 3 is given to us and then the blank which is being given to us. Uh, okay, that simply reflects that there is one edge between 1 and 2. And then 3 is empty, then again 3 is there, and then 1 means blank. But now this will be representing that 0, then 1, then 2, and then third. Means basically this 1 and 2 which is given to us at the 0 index, means ith part, these are given to us. Complete adjacency list by themselves they have given to us. That 0 is being connected to 1 and 0 is being connected to 2, which we can see here in the graph. Then 3 is being given to us at the index 1. It reflects 1 to 3. Now, 3 is again given to us at second index. So that simply represents that I is being connected to j. That is what is being given to us. So that simply means that adjacency list is already given to us. So we don't need to form a separate adjacency list of our own. So that's why we can utilize this input and directly traverse. So now comes the part that how we will be traversing, and is it just direct DFS or we also require backtracking. So for this particular thing, we can directly see that when we do DFS on this particular portion, we got one path, right? Then there could be a possibility if this particular node was connected, if by chance, right? So we are also required to track that path also, right? So that's why we are required to do backtracking in the same. So that's why we will be popping out this particular path and then checking that is one connected to any other path? No. Then we will be again popping this out. Then we will be checking is 0 connected with any other path? Yes. It is connected with 2 as per this question and even means as per this input, and even if there was case that it is directly connected, then we would have taken this path also. So that's why here we are required to do backtracking as well with the DFS part. So that we will be required to keep a check on this particular. So now comes the part that how we will be going ahead with storing paths or what we will be doing. So the thing is that we will be directly doing DFS, and then in the DFS part, we will be passing our this graph which is being given to us, and then passing our result vector which we will be taking, and then one path vector which we will be taking, and then one source. That's the thing which we will be passing. This result will be storing all our possible paths. So that would be the thing here. Because here the input type is vector or vector end. So that's not input, the output type is vector or vector end. So that's how this will be vector or vector end, a 2D vector in which all these paths, which is a particular vector only, that would be stored. So this is how we are required to form a DFS function. And in this DFS function, we will be checking each node of our adjacency list and corresponding to that, what all connected paths are there, that we will be checking. And accordingly, and the base case for this DFS would be that if our I, which is if it is equals to graph dot size minus 1, if it is equal to this, that simply means that it is equal to n minus 1th node, right? So as per this particular situation, we can directly push that particular part to our result vector or vector. So this is what we are required to do in this particular question. So now let us move ahead for a coding part. So here's the coding part for the same. So I'll also explain you with the time complexity as well. So 1 minute, I'm just trying to scroll it. Okay. Hmm. So here's the coding part for the same. So first we are taking the result vector which we will be returning because the type of this function is vector or vector int. Then this vector int path, that is our auxiliary vector which we are taking, which will be containing all the paths that we are required to push into our this result vector. So that's the thing. Now here we are calling our DFS function and at the end we are returning the result. So now in our DFS function, what we are doing is we are first pushing the source which is there, and then first check is that if our source is basically equal to the graph.size minus 1, that is n minus 1 node, then we are directly pushing that part to a result. Else, if that is not the case, then what we are doing is we are directly checking that particular node in our graph, means basically in that adjacency list, and then extracting that node and then pushing, making that particular node as our source node, and then doing the DFS. After doing all the DFS call, when it comes to the path of backtracking, then we are popping out the last node from our path. So that's the thing which we are doing here. And according to this only, we will be getting our final answer that all the number of paths which are being there. Basically, this question is all about doing DFS plus backtracking on a graph. And thus it is an easy level question. I don't know what is the type they have given. It should be easy level question only. Hmm. Course I had. It is medium level question, but the thing is that this is the basic understanding question that how we are required to do DFS on a graph. Now comes the part for the time complexity and the space complexity. So now the time complexity is power of 2 raised to power n into n. And how is the same? See, at the starting I had explained you that if 0 is there and 1 is there, right? Means only two nodes are there. Then the number of paths would be 2 raised to power n minus 3, right? If 0, 1 and then 2 is there, right? Either it could be direct, means 0, 1, 2 should be there, right? So again, it becomes n minus, 2 tha. I guess it was 2. So 3 minus 2, that is 2 raised to power 1 path, right? So like this, only at max this much path could be there as we increase the number of nodes. So as per that only, there could be at max 2 raised to power n minus 3 node, right? And into n simply refers to the number of nodes we are going ahead with the same. And the possibility of path could be 2 raised to power n only. So that's why the time complexity become 2 raised to power n. And same goes for the space complexity because after all we are storing those number of paths only, right? That's why we are storing those number of paths in our path vector, and that's why the space complexity become that only power of 2 raised to power n into 1. So yeah, this was all for this particular question. If you have any doubt, you can comment that down. If you were not able to understand any part of this video, you can comment that particular portion, means that timeline as well. I'll explain you in the comment. So yeah, this was all for this particular question. If you like the explanation, then please do share among your friends as well. So this was all. Thank you. Stop the video.